Resistance is kind of like a drag force. So all it is, it's just friction. So what it does is it acts in the opposite direction of motion when it's going down or across uh, if it's falling. So it is a force. We usually indicate it on our free body diagrams as FF. Imogen, how far did you get on the thing we posted through the government website? Did you finish the whole unit? Hey, Trent. You said, is the net force the sum of all forces in opposite directions? So net force is like the total force acting on an object. So if you're pushing uh, right and left, so we have like an applied force and applied force this way, we add them all together just like we would like a displacement. So when we're trying to find the displacement of someone walking left or right, net force is the exact same. So if we have like 15 Newton force this way and a 15 Newton force this way, the net force is 0. Hi, everybody. Oh, hey, John Ross. I'm just seeing if I AirPlay my iPad to this screen, do you think you guys could see it? Probably not. Okay, so Maggie says, can you go over question 4 on the universal gravitation? Okay, sure, I'll bring that up. Okay, so Maggie, you say in your free body diagrams, you identified 2 forces of gravity. Basically, all you're saying is that the gravitational force of the planet is so much bigger than the gravitational force on the astronaut. So if you're drawing a force body diagram, a huge vector for the planet and a very tiny vector for the astronaut. That's pretty much it. Trent, for one question on yesterday's, to draw a free body diagram and the net force equation, but we're not given how many units of force are present. Good question, Trent. So a lot of this unit, okay. The homework question. Okay, I'll have a look. So Trent, just to answer your question, so a free body diagram with a net force equation not present. What you should be able to do is that, so you have your FBD, right, which is like, you have something like this. So you have FA, oh, it's a mirror. So if you have FA going one way and then FF going the other way. So an F net equation without units is just going to look something like this. So where F net is equal to FA minus FF. Right? We use those a lot without any units. Does that make sense? Yeah, so if you have something like, if you have more than one force on it, the F net equation, you just go, so F net is equal to FA minus FF minus FD, or drag force. Okay? Cool. Okay, Maggie. So how far above the Earth's surface would you have to go to lose half your weight? So remember, weight is equal to Fg. So if Fg, I know you can't see what I'm saying. So if Fg is equal to big G m1 m2 over r squared, all you do, oops, this is not, I need a better system here. All you do is when you take Fg, just do 1/2 Fg, and then you have to solve for radius. So you're not going to get, and then put in, for radius, you want to put in the Earth's radius, so from the core to the surface, and then you're solving for that distance up here. So r plus x. So then you're going to end up with 1/2 Fg, and Fg is just equal to mg, and then you can work from there. Does that kind of make sense? Right? So you have something like that, and then just rearrange for R. It's just a little, you can either keep it all as variables or plug in the Earth's mass, but you don't know the mass of the astronaut. But remember, so if you can do this, 1/2 mg equals g mass of the Earth, mass of the person, over r squared. So if you have this one, this mass of the person is going to cancel out on both sides of the equation. So you're just going to end up with 6.67 times 10 to the negative 11 times the mass of the Earth. We're looking for R, and so it's just going to be 1/2 g. Good? Maybe I'll back up closer to this and airplay it for next time. In question 1, what force is being applied to the bottom of a fishing lure? Yes, yeah, tension force. Anything on a rope, chain, whatever, string is a force of tension. And so in your F net equations, you only have to put Ft. Something like this, F T. Trent, is the video, well, the PowerPoint yesterday and the video from Khan Academy, is that sufficient enough, or would you guys like my own video? And Maddie, if you're still here. I'm not really sure which question it is. So is there, on the bottom, yeah, it's going to be just a gravitational force. So Fg. Fg is going to cause it to sink. You don't know how to do that yet, Trent, but next week's lesson will tell you to do it. But just FYI, so you just use Newton's second law. So F is equal to mass times acceleration. And then so if F equals ma, all you need to divide the Newton force by the mass of the object. That's going to give you the acceleration. I think so far you only know how to do free body diagrams. The lesson coming out will tell you, we'll go through Newton's 3 laws. Jacob, for the fishing question, the water force going upwards. Yes, exactly. That's exactly it. So the water force is going upwards, and in this case, it's going to be like the drag force or the friction force is what the water provides. So your free body diagram is going to just be, and then the force of friction and force of tension going up. But usually when the lure is going down into the water, the tension really isn't there because it's kind of just sinking. Hey, Megan, just got your message on Classroom. You can just type them in the box and I'll respond. Just like you sent that notification. So is the drag from the water or the tension in the fishing line? Good question, Jacob. I'm going to say in this case, it's more from the water than the tension in the fishing line. If you're pulling the fishing line up, then there's the drag of the water going in the same because it's moving upwards against the motion. And then if you just go up, 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 then the force of friction going down, force of gravity, force of tension is going up. But if the line is just sinking, the drag from the water is going to be going upwards. The tension of the fishing line is going to be upwards as well, but it's going to be pretty tiny because when you drop a lure in, obviously you're not trying to go up and up and up. And then the FG is still going down. I'll draw it out on my iPad in the equation. Okay, so when the lure is falling down, it's going to look like this. So the gravitational force is pulling it downwards. There's a tension force upwards and a force of friction upwards. But then if you were to take the lure out of the water, it would still be flipped. So you're going to have FG going down, FF going down, and then this tension force going up. Carly, when calculating the net force, how do you include the mass of the object in the equation? Okay. So Carly, we really haven't got there yet, but since we're on here, so there's something called Newton's second law, which we'll get to next week. I didn't really know how much work to post for you guys because I didn't know how much everyone was really super excited to do physics. So for F nets, F nets are always equal to the mass times acceleration. So that's Newton's second law. So the net force, so all of the forces acting on the object, is equal to its mass times acceleration. And remember, acceleration is that change in movement. So if your F net is equal to FA minus FF, or something like this, F net is equal to FA minus FF. And let's say we have a 15 Newton applied force minus a 5 Newton frictional force. That means it has a net force of 10 Newtons. And then let's say that this 10 Newton force was acting on a 5 kilogram object. So all we do, because we know F net is equal to MA, all you do is you take 10 and divide it by 5. So A is equal to 10 Newtons divided by 5. And then so you know that this object is traveling at 2 meters per second squared. Does that kind of make sense? We get more into it next week. Megan, just got your question. Yes, that you can totally solve by trig for that static equilibrium. Is the question 3 is the one where it's at the same angle, right? Oh no, sorry, question 3 is this one. It's just 2.5. And then basically all you're doing is you're flipping those vectors into the new triangle here, right? Where ft3 cos theta and ft3 sine theta. So basically you're just flipping the vectors and using Pythagorean theorem. That's all good. It all works. I know you can't type anything, but I hope that's okay. This is a free body diagram, Trent. So after this one's actually super easy. So when the space shuttle goes down, the only force acting on it is force friction. And I guess the force of gravity, force. So it's going to look something like this. The parachute's going to provide a frictional force or like an air resistance force. But so all the air resistance forces, we make it as a frictional force. So there's three forces on it: frictional force, the normal force, which is the opposite of the gravitational force, keeping those two objects apart, and that's it. So FF, FN, and FG. And Trent, I just took another look at the homework. I'm gonna upload a video probably this afternoon. I'll have to drive to Brisbane because my internet is poo poo. I'm just on my data right now. So what I'll do is I'll upload that video discussing. There's no applied force going forward because when the shuttle lands, if it's trying to stop in time, putting on the engines is probably counterproductive. So yeah, there's no applied force going forward. Kind of like trying to brake when you're still pressing the gas. Yep, exactly. So remember, as soon as that ship goes down, as soon as the parachute is out, it's going to stop. It's going to start accelerating in the negative direction, right? So it has inertia or momentum to move forward, but as soon as the parachute goes, it's going to start accelerating the opposite direction. So even though it's moving, there's no force acting on it going this way. Yes. Always in your net force is going to be 0 on a stationary object, and net force will also be 0 on an object that's no longer accelerating. So if you have equal forces, so like if you're cruising up in the air, that's why you don't get pushed back in your seat or pushed forward. You only get pushed forward or pushed back when you're accelerating. So if you're still applying or cruise control, right? If you're cruise control on your at 80 kilometers an hour, that's going at a constant speed. So net force, so all the forces of your engine and the drag force and the brakes and on the tires and the wheels, it's going to all equal 0. Even though you're moving forward, it means that you have a net force of 0. So stationary objects and objects moving at a constant speed have F net of 0. Hey, Michaela. If you scroll back in this video, I actually answered that questions for Maggie. Oh, see, there you go. Yeah, I don't know whether there's a timestamp or something, but yeah, I think it was probably one of the first little bit. I think that this post this can be posted to the classroom after we're all done. I'm not sure whether you guys can see the chat when it gets posted, but we'll troubleshoot that out. Is this effective? Like, is this a manageable thing, or should I switch to a different platform? Google Meet won't work with you guys because it's not a green tool or something like that. So it's a privacy issue. I'm not even sure whether this is allowed, but I'm going to do it. But if this is effective, then that's good. It's super awkward for me. I feel like I'm just talking to myself. Yeah, I have Zoom on my computer. I didn't know whether whether that would be effective or not. Maybe I'll try Zoom next week. Okay. I don't know whether Zoom can. What I was kind of worried about is that Zoom can't be recorded. Because so people that can't make the office hours, they can always come and watch the video after. I know it's a lot of me just looking at the camera, but maybe I'll go through after and just tag where I answered specific questions. But yeah, we'll try Zoom. I'm actually really surprised that people even showed up. So. By package, you just mean that worksheet that I posted, Carly. You can do 1 and 2 with the thing that's on right now. I'm using my phone data right now, but this afternoon I'm going to drive to Brisbane and upload the video. So there'll be a video going through Newton's 3 laws that'll allow you to finish the rest of the package. Yeah, so just do 1 and 2 today, and then you'll be able to do the rest of the week. Is that an acceptable amount of work for you guys? I don't know whether, like, I know a lot of you guys are working. Have you guys been getting a lot of work in your other courses? I don't want to overload you, especially the grade 11s. I don't really want to overload you and get you all stressed out. And because I'm going to be honest, you're not going to get the same amount of work as the usual course, and we're just going to be playing catch up in grade 12 anyways. So I don't want to stress you out just for now. Grade 12s, again, same thing. 3 hours of work isn't enough to do a 4U course. So I'm just going to try and teach you guys some stuff that will get you to like first year university a little bit. But we'll try our best to get through some stuff. Does the weight of an object affect F-net? Or is that just for finding things like? So I'm assuming you're meaning mass. Weight, we haven't gone through this yet, but so weight is Fg. So your weight is your gravitational force times your mass. So it's the force of gravity, where your mass is just how many atoms make up your body. So the weight or the mass of the object does affect F-net. So if you increase, just think of it when you try and move, if you're trying to move a massive fridge compared to a mini fridge, you're going to need way more force to move a big fridge than a small fridge. So the mass affects the F-net definitely. And Carly and Trent and Jacob, if you want to get started just by knowing F-net is equal to mass times acceleration, you can solve the rest of that sheet, I think. So you probably could get a head start. You shouldn't be playing Fortnite. You should switch to the new COD, Warzone. It's way better. Fortnite is for children. No. Hey, Michaela, I think it's just going to be the one on Friday is just going to be multiple choice or formative. I still don't really know what we're going to do for assessment in that course. I think it's not really fair to give any grade, to be honest. You'll see that I gave you guys the observation grade, which I think helped a lot of you guys for midterm marks. But I think I'm going to offer two options. For the quiz Friday, it's just going to be multiple choice on Google Forms. So you don't have to type it out to see your calculations. But on next week, when we do our actual test, you'll have the option of submitting it in a Google form or printing it out and taking a picture and sending it back. Okay, everybody. It looks like we're done here. My computer's running, so we will see you guys Thursday at 10 o'clock, same time, same place. And for grade 11s, I will upload a video tonight, which includes a pretty sick TikTok. I'm not going to lie. Spoiler alert. And we'll see you guys later, okay? Also, if you have any other questions, feel free to email me outside of office hours. And it's all good. And hopefully this works. Oh, I don't know. Oh, yeah, smash the subscribe button.